Read. Study the circuit diagram given below. You are given one extra resistor. By drawing a new circuit diagram, show how you can connect the extra resistor to increase the reading on the ammeter in the circuit. So we want to increase the current, guys. So what connection we have to make? Series connection or parallel connection? Series or parallel? Anybody?
Parallel.
Parallel connection. That's all. You make that, answer will be over. Everybody has to do it. If you make it, that's all. So what is the connection we have to connect? We have to connect to increase the ammeter reading. We have to connect in what connection?
Parallel.
Parallel connection. Because parallel connection current increases, series connection resistance increases. Prima. So current decreases automatically. So Ohm's law, both are inversely proportional to each other. That's all. Next, Priya has a copper wire and an aluminum wire of the same length. Very, very important. Can the electrical resistance of the two wires be the same? Justify your answer, they are asking. What is your views? You tell me. Based upon that, I will proceed. Hari, what is your expected, Hari?
Changing the temperature, you can mix in the system.
So what is your expected answer? That's what. Others, answer yes or no. First, adi sollunga. Yes or no. Everybody? All of you? Yes or no, guys? No. Answer yes or no. At least try to say, you don't have that opinion also.
Yes.
Yes?
Yes.
So we all knows that resistance is depends on mainly two factors. Forget about temperature and nature. What is the first two factors?
Length and area of cross
Length and area of cross section. Area of cross section also we can say is radius and as well as what? Radius and diameter. Now they are saying Priya has a copper wire and aluminum wire. So one is copper wire of same length. Just why I'm drawing single line, same length. But they are not talking about the area of cross section. So I'll make different area of cross section. Let me take this is the copper wire and I'll make this is the aluminum wire. Different area of cross section. But length is remains what? Length is remains what?
Same.
Remains constant. So is it possible or not? Yes or no? Can the electrical resistance of the two wires will be the same? Justify your answer. Yes, it is possible. Because we all knows that resistance not only depends on length, it is also depends on what? It is also depends on, yes please, area of cross section. So we can make, by making the different area of cross section, even though length is same, if area of cross section is different, area of cross section also call it as some other name. Anybody can tell? If you are using diameter, we have to use that one. Anybody? Yes, please. Diameter, if it will comes, we have to use a word, call it as a thickness. So thickness of the wires, maybe the length is same, but different thicknesses will be attains the same resistance. That is what is the answer. Remember, if you are yes, if you write, your mark is not given unless you write the justification. Justify your answer. So what is the answer? You have to write resistance is not only depends on length. So of course, nature of the materials matters, but variable conductors of variable area of cross section, we people attains the same resistance. While teaching time also, many a times I mentioned this point to you people. So even though the materials are different, if the length is remains same, but where area of cross section is different, so we people will attain the same resistance. Understand everybody? Yes, please respond. All of you.
Yes, sir.
Yeah. Next, three resistors in a circuit are attached is shown here. E, F, and G. So of course, all are in what connection? Everybody. All are in what connection? By seeing itself, you can say. What connection they are?
Parallel.
Parallel. The resistance of F and G are 10 ohms and 5 ohms. F and G. This 10 ohm. This is 5 ohm. The resistance of E is unknown. The resistance of E is unknown. These resistors are connected to a battery of potential difference 6 volts. So, they are asking us to find the E value, if my guess is true. So, in potential difference, always, what is that anybody can tell? Potential difference in a parallel connection always remains what? Potential difference. V is always remains what? In across every resistor. Remains
Constant.
remains constant. Now, all of you observe very carefully. So, what is the term used to describe such an arrangement of resistors? What is the term we are using here? Anyone?
Parallel.
Parallel. What is the resistance of E if 0.3 ampere current flows through it? Wow, they made our work very easy. So, what is the current passing through the E? Everybody? What is the current passing through the E? Anybody? 0
0.1
ampere. Means current
amperes.
I know and I want voltage is remains constant. So voltage எனக்கு தெரியும். Let me take this is I1. I1. So V is equals to remains constant. Cannot find R1. R1 means E. So RE. So what is the formula? RE is equals to V divided by I1. Am I right, everybody? 6 divided by 0.3. Can you tell me what is the resistance? Make it quick. 6 divided by
20.
0.3, 6 divided by 3, which is equals to 20. Very good. That's it. Make it quick. Purima. Concept Purima. What is the total current flowing in the circuit? Total current they are asking. So there is a two ways to solve the total current. Anybody tell? Both methods I'll teach you, observe. So I already know I1, then I2, then I3. I'll find this way. So I2. What is I2? Anybody tell? So that is what RF is equals to V divided by I2. So I2 is equals to V divided by RF. So what is the V6? RF value 10. So 6 by 10 means 0.6 amperes. Next, I3. I3 is equals to V divided by RG. 6 divided by G value how much? What is the G value? 5. So 6 by 5 is equals to something. Anybody tell? 6 by 5 is equals to 1.2. So what is the total current? Is equals to I1 plus I2 plus I3. I1 is 0.3 plus 0.6 plus 1.2. What is the total current? Anybody? Total current 1.2, 1.8 to 2.1. 2.1 ampere. Any doubt anybody can ask me. Harish, understand? Clear? Mr. Sanjay? Noor? Respond, guys. Mr. Pugal solving
sir.
out. Abhirami,
Yes, sir.
make it fast. Asin, Naveen.
Yes, sir.
Next. There is another method. What is the another method? Anybody tell? You all knows.
Total resistance.
Yeah,
Total
total
resistance.
resistance. That's all. Because total voltage theorem, 6 volt. Total resistance in parallel. So what will happen? 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by R1, 20 plus 1 by R2, 10 plus 1 by R3, 5. What is the LCM? 20. So 20 means 1 plus 2 plus 5 4 is 4. So which is equals to 7 by 20. That is what RP. So from that, resistance is equals to 20 by 7. Any problem? Anybody? Clear?
Yes, sir.
Now total
Yes, sir.
resistance per year. So total resistance is 20 by 7 and total voltage is 6. So R is equals to V by I is equals to V by R. So V is 6 divided by R is 20 by 7, which is equals to 6 into 7 by 20. So 2 3s are 2 10s are. So which is equals to 7 3s are how much? 21. 21 divided by 10, which is equals to 2.1 ampere. Exact answer. Purima. The method of solving is purely for your purpose. So it is your choice. Nobody will compel you to solve. Only this way is right. Adi ungal comfort, yeah, which method you are familiar, you can solve. There is no compulsion at all. But I1, I2, I3 is always easier because parallel connection, we all knows that sum of the individual current is equals to total current. So why I am suggesting this exercise, there is a question where every book, every resource, every material will follow. They will calculate individual resistance and they will try to find the total current. But if you use a technique, what is the technique? I1 and I2, then we people can easily complete this question. Question number 15. Every book, including H-Chand, you see how big it is they used to solve. So that is what you have to remember. Clear, everybody? Understand, all of you? This question you might be remember. Am I right, Harish? Correct? So if you solve normally based upon the H-Chand method or you take any Google methods, so people used to solve individual resistance has to be calculated and then total resistance, and it will leads to extremely tough complications, like calculations are very tough. So that's why better always go with the individual current. So we all knows that what will happen, everybody? In parallel connection, individual current is equals to what? Total current. Am I right, everybody? Individual current is equals to total current. Yes or no? All of you. So sum of the individual current is equals to total current, so that you can easily solve it. You'll get the answer also. So you can see here how big they will solve the same question. Question number 15. Two lamps, one rated 100 watt, 220 volts. 160 watt 220 volts are connected in parallel. So what is the current drawn from the line of supplied voltage? You see that how big it is. They are getting R1 and R2 values individually, and then they are finding the equivalent resistance, and then they are using the Ohm's law formula, and then finally they are getting 0.73 ampere. So instead of that, directly we can do one thing. What is that, everybody? Individual current we can find. What is that? P is equals to VI. I'll write P1 is equals to V1 into I1. P2 is equals to V2 into I2 over. So I1 plus I2 is equals to I, total current. So what will happen? I1. So I1 is equals to P1 divided by V1. I2 is equals to P2 divided by V2. So what is the P1 value? Everybody? Power value how much? 100 and 220. So 100 and 220 means 100 and 220. Then this one, how much? 60 and 220. Am I right? Yes, Ra. So what will happen? 5 ones are 5, sorry, 2 5s are 2 11s are. Same way 0 0 get cancelled, 2 3s are 2 10s are. So what is the answer? Wrong, right? Doing 220, correct? Yeah, 220. So 3 by 11. So 5 by 11 plus 3 by 11, which is equals to 8 by 11. I1 and I2, which is equals to how much? 0.67. So which is easy to solve? Everybody. Current calculating. So always remember, in parallel connection, sum of the individual current is equals to total current. Use this technique to solve it. The same question, you have same method you have to use here also. Okay. Next, You have given 3 identical 10 ohm resistors of 12 volt cell. Draw the circuit diagram to show how the resistors can be connected with a 12 volt cell so that the total heat produced in the circuit is minimum. So in which connection minimum heat will produce? Parallel or series? Yes, please.
Parallel.
Connection, parallel, that's all. So they have given 3 identical 10 ohms. So 3 identical 10 ohms. So minimum heat has to be produced. So that must be connected in what connection? Everybody? They must be connected in what connection? All of you. Yes, please. Parallel connection. That's all. That is only your answer. Okay, everybody? Understand, Ra? Yes, but they're asking 1 minute. Draw the circuit diagram. So to show that how the resistors can be connected with the 12 volt cell so that the total heat produced in the circuit is minimum. Is it parallel or series, Amma? Anyone? Because 1 minute. Resistance is high, but H is developed, H is equals to 12 ohm resistors, 10 ohm resistors. So 1 minute, Amma. Wrong answer. So whenever they will ask about the heat, you have to use a concept called it as a Joule's law of heating. According to Joule's law of heating, H is directly proportional to what? Everybody? H is directly proportional to what? I square. Correct? Yes. So when the when the current is less, everybody, parallel connection or series connection? Parallel connection or series connection?
Series.
Series connection. Sorry, Amma. So even if you take all of you observe, we all knows that H is directly proportional to R also because H is equals to I square RT. So we all knows that in parallel connection, it will produce the less current across every resistor. Current will be splitting I1, I2, I3 so that we won't get a sufficient amount of what we can say is here current will be maximum because parallel connection more current will passes so that we will get, of course, they're asking maximum heat means it is parallel. They're asking minimum heat. So minimum heat means they are connected in series connection. What will happen, everybody? Current will be less or more? Everyone? Series connection, current will decreases or increases? Series connection, current will? Series connection, current will, what will happen? Decreases. Yes or no? All of you. If you connect them in parallel, the current will increases. If you connect them in series, current will decreases. So current decreases, heat energy also decreases. Minimum they are asking. So minimum means, please remember heat energy, we have to connect them in series. Maximum means we have to connect them in parallel. So please write it. Okay. So they have been connected in series connection. That is what you have to remember. Okay. Then up to here is all. Question number 13 is the most important question. I'm giving chance for you people. You try to answer. If you are not able to answer also, I will explain you personally. This is one of the very, very CBQ question. So very challenging, not? It's very simple question. If you have a basic knowledge about parallel and series connection, so you can directly answer this question. So it's not a big deal. So just go through that and then we'll discuss in our next class. But after we'll meet shortly by 10 o'clock. So try to revise. Anyhow, coming Tuesday, physics slot 4. So try to make it and bring your physics classwork, NCRT. You have HM book. I know everything. Try to bring it. Today we are going to practice for that only because tomorrow you have school again. So there is no time. Actually, I plan to take tomorrow also. But tomorrow there is a school, so you cannot take. So you have to today we mostly have to finish it. So come sharply by 10 o'clock. We'll try to finish it at least one or two chapters. Okay. Thank you everybody. We'll meet by 10 o'clock.